So I just looked at the video I made and I realised that my face is going to appear and obscure some of the writing. So you missed a few parts of that previous lecture. I'm not going to re-record it though. So I'll try from now henceforth. There was an easy example. You knew the answer. You can see it and read what was the missing letters. But I'll try to be a bit more careful from now on about where I put my face, about where I put my writing. My face is going to appear down there. Okay, so we did that very simple example. I like to show things through an example first and then to do the general theory, and then we'll look at the actual solutions. So a very trivial examples are great. You learn a lot, and I find in maths, if you try and understand something, try and find the simplest example you can of how it would work, and then work from there. That was an adage of Fermi or something, or someone quoted it as being an adage of Fermi. So find the simplest problem you can. Okay, so we've seen that, how would it generalize? So what we've got is a problem that looks like this, the time derivative of u. So we could solve this by time stepping. We're not going to talk here about the numerical methods, but you can time step this equation. Perhaps they should do some numerical solutions of these as well. So that's the general form there. So the time derivative is equal to, that should be the x derivative. The time derivative, and we're just assuming now that x goes from minus infinity to infinity. Boundaries become a little bit trickier here from t is greater than 0. So we just, again, remember this is a linear equation, so you can, superposition works, and the method of characteristics works. There's lots of other ways of solving this as well. But we're just illustrating how these characteristics work. So again, this is the general case. We set up xt is equal to, we use this notation, so that that's the curve. Big X is the curve of the function. And then we go d by dt of u of x of t, comma t is dx dt du dx plus du dt. Okay, and then we go, well, du dt is, it's big X dt times the derivative of x with respect to u minus a of x comma t times the derivative of x with respect to u from the equation. So it's equal to the x derivative of u times, be careful here, I don't get too down to the danger zone here, but I'll just appear. When my face appears, there it is there. Alright, brilliant. So we want that to be equal to 0. So that's going to equal 0 if we have dx dt. Oops, and I'm going to be careful here. I'm going to write it down here just in case I get covered up. If dx dt equals a of x comma t. So that's the equation for the characteristic. It's an ordinary differential equation, and you solve that ordinary differential equation, and then that gives you the characteristics. They might curve or do all kinds of crazy stuff, but they'll fill the space, and then you trace those characteristics back, and you know that on those lines, so that leads to a solution, gives a solution x of t, on which u is a constant. All right, brilliant. So let's go and do an example here. I'm going to clear this. Okay, remember this is all straight out of the notes on that page. We're just going to do through some examples on the page. Okay, is that 1, 2, and then in homogeneous there's 3 examples. I'll do 1, and then I'm going to have a break, and then we'll do the last part last. Change colour to something blue. I love the different colours. I'm sure that really helps you out learning. Okay, so here's our example 1. Okay. So it's the time derivative of u plus x times the x derivative of u equal to 0. Okay, so I'm going to go through this. You can just jump straight to the formula, but I'm going to derive it again. And u at t equals 0 is f of x, some arbitrary function. So I go x comma t is big X of t times t, and then I go, I find the time derivative of u of big X of t comma t, which is equal to the x dt times dx of u plus dt of u, which is equal to dx dt minus x. Multiplied by dxu. Okay, and so the characteristics are given by dx dt equals x, which is solution, okay, simple equation there, isn't it? X of t equals c e to the t. So what we know is that on u of c e to the t comma t, u is a constant. Let's write this thing here. This is equal to a constant. Okay, and if we set t is equal to 0, so that's the thing, that's the curve there. Those are the characteristics, and I can draw a picture of those. Right? So it's a family of exponentials. Here's x, and here's time. So take another colour maybe to draw them purple. It's a bit weird because you normally draw them the other way, but they come out like that, throwing away. And then they come out of here, these are the ones decaying. That's what the characteristics will look like. So on these curves here, u is a constant. Okay, so we've got to trace it back here, and this, of course, is given by f of x, right? Whatever the value of 0. Okay, so we set t equal to 0, and we get u of c e to the t, comma 0, must be f of c e to the t. Whoops. Let me just go back a second here, being silly here. T is equal to 0. So it's t is equal to 0. We're going to have u of c, comma 0 equals f of c. Okay, so we're basically finished now. We just got to solve for c. So from here, we can rearrange this and get c as x e to the minus t. Right? So we have u of x comma t is equal to, this is x, right? It's a constant, which is f of c, which is equal to f of x e to the minus t. Brilliant. Okay, and if you go and look at the notes, you'll see that a little picture of the solution here, and maybe that's helpful to see right now. All right, I'm worried my head might be in the way here. So let's move this across to here. There's the picture of those characteristics coming out, and there's the example of the Gaussian, and you can see here how the solution smears out. So this is the Gaussian pulse here, and according to this equation here, it's the solution gets carried on these characteristics, so it sort of flattens out like that. So the picture here of the solution in X is drawn as like a waterfall plot, they're called, with these lines going forward in time. Okay, and remember, if you click on that, you'll find the code for how to do that and how to draw that picture and draw the characteristics. You're asked to do that for your assignment. Okay, I'm going to finish there for this part and then I'll do the next two examples.